Imagine we could shrink down smaller than an ant, smaller than a grain of sand, even smaller than a human cell. We'd find ourselves in a world that seems completely alien to us, a world ruled not by gravity and laws of motion as we know them, but by forces and particles that behave in truly mind-boggling ways. Yes, we're diving into the microscopic universe inside an atom, exploring the spine-tingling intricacies of electrons, protons, neutrons, and the elusive quarks. Let's start with the basics. Everything around us is made up of atoms. An atom can be pictured somewhat like a tiny solar system, with a nucleus at the center and electrons orbiting around it. The nucleus, dense and compact, contains protons and neutrons. And here's where things get interesting. Both protons and neutrons are further made up of quarks. Let's zoom in on the electron first. These are the vagabonds of the atomic world, roaming the outskirts of the atom. Electrons are incredibly light, around 1,800 times lighter than a proton or neutron. They are negatively charged and create a cloud of electric charge around the nucleus, which dictates how an atom interacts with its neighbors and forms molecules. But electrons are more than just particles. They behave like waves too, spreading out around the nucleus in what we call orbitals. Each orbital has a different shape and energy level. The peculiar behavior of electrons as both particles and waves is central to the weird world of quantum mechanics. Next, let's tackle the nucleus, starting with protons. Protons are positively charged particles found in the nucleus. The number of protons defines what element an atom is. For example, an atom with 1 proton is hydrogen, while an atom with 6 protons is carbon. Protons are made up of 3 quarks, 2 up quarks and 1 down quark. These quarks are held together by something called the strong force, mediated by particles known as gluons. It's an immensely powerful force that acts at extremely short ranges and is responsible for holding the nucleus together. Neutrons, the neutral partners of protons in the nucleus, play a crucial role in atomic stability. They are roughly the same size as protons, but have no electric charge. Neutrons are also composed of 3 quarks, but unlike protons, they have 1 up quark and 2 down quarks. Neutrons are crucial because they can add to the binding energy of the nucleus, helping it stay intact. Without neutrons, most nuclei would fly apart due to the repulsive electric forces between the positively charged protons. Now, let's delve even deeper to quarks, the fundamental constituents of protons and neutrons. Quarks come in 6 flavors: up, down, charm, strange, top, and bottom. Protons and neutrons are composed of only up and down quarks, but the existence of other quarks suggests the universe has some hidden layers we're just beginning to understand. Each quark carries a fractional electric charge, and their combination in threes results in the overall charge of a proton or neutron. One of the most baffling features of quarks is that they are permanently confined by forces coming from the gluons, the carrier particles of the strong force. This phenomenon, known as quark confinement, means that quarks cannot exist independently outside of protons, neutrons, or other particles. Instead, they are always bound together, forming composite particles. This is why we have never observed a free quark, and probably never will. To add one final twist, what's truly fascinating is that the mass of an atom isn't primarily from the quarks themselves, but from the dynamic and energetic interactions between them mediated by gluons. Essentially, most of our mass comes from this binding energy and the movement within. This exploration through the inner parts of an atom not only showcases the enigmatic nature of the fundamental particles, but also illustrates the complex and beautiful tapestry of physics that constructs our understanding of the universe. Each layer, from electrons to quarks, highlights sophisticated interactions that are continuously occurring on scales far beyond our everyday perception. In this tiny, bizarre, and profoundly intricate world, the foundations of everything we see and experience are continuously dancing to the quantum tune. As we piece together this puzzle, Each discovery paves the way for deeper questions and more awe-inspiring revelations about the nature of everything.